Okay, so today we are working on solving systems by substitution, day number 3. Our content objective is students will be able to solve systems of equations by substitution. Our language objective is students will be able to explain the steps to solve a system by substitution. Why am I learning this? Well, it's important for real life problems like, when will two cars meet up if they're driving at different rates and they are at different starting points? So first, let's go over some background knowledge. When solving systems of equations by substitution, step number 1, you want to make sure to have one variable that is already solved for. So in other words, you're looking for something along the lines of x equals an expression or y equals an expression. Step number 2, you're going to substitute that resulting expression into the other equation. Step number 3, we're going to solve that equation to get the value of the first variable. And by first variable, there's no particular order. It doesn't matter if it's x or y. Step number 4, you're going to substitute that value into one of the original equations and solve for the other variable. It's very important that you use an original equation. And step number 5, write the values from steps 3 and 4 as an ordered pair and make sure you write it as x comma y. Some of my students do write it backwards. And last but not least, you better make sure you check. Okay, so on that note, we're going to go ahead and start on our very first example here. Remember from the previous lesson, we stressed that it's important that we at least have one equation that's already solved for. In this case, we're going to use this one. Why? Because we already know the value of a y. Y in this case is 2x minus 1. Of course, this is not an appropriate answer to put in your ordered pair, but we can definitely use this piece of information. So since we know that y equals 2x minus 1, we're going to go ahead and substitute this in for y in the other equation, because that's what y equals. So here I'm going to get x plus, I'm going to substitute the value for y, which is 2x minus 1 equals 5. Now here, technically there is a 1 out front. Okay, you would be distributing that, but we understand distributing a 1 really doesn't make a difference, so you don't have to. You just need to be careful. If this was a subtraction, it would be crucial that you did. So just for the sake of it, I'm going to go ahead and distribute that positive 1, which would give me 2x minus 1 equals 5. At this point, I'm going to combine like terms. I'm going to combine a positive x with a 2x, which is going to leave me with 3x minus 1 equals 5. Here you would then get rid of your constant by adding 1 to both sides, leaving us with 3x equals 6. Divide both sides by 3, leaving me with x equals 2. However, I'm not done. What I'm going to do now is take this value here and substitute it into x. Okay. So now, why did I choose this one instead of the first one? Well, this one's already set up as y equals, so this would save me a lot of time. So I'm going to go ahead and set it up. Y equals 2 times x, which I figured out to be 2, minus 1. So here, y equals 2 times 2, which is 4. 4 minus 1 is 3. So now that I know the value of y is 3, the value of x is 2, I can go ahead and say the solution is 2, 3. Why? Because x's are always written first, y's are always written second. But you know me, we're not done quite yet because we still need to check our work. So let's go ahead and do that. So I already determined that the solution is 2, 3. Remember, I want you to take the 2 seconds it takes to go ahead and label that, hey, x is 2 and y is 3. So now that I know the values, I'm going to go ahead and substitute it into both equations to make sure it works for both equations. And you can't stress that enough. It must work for both, not just one of them. So y is a 3, so I'm going to put 3 equals 2. Instead of x, I'm going to replace it with a 2 minus 1. So here we have 3 equals 2 times 2, which is 4, minus 1. Does 3 really equal 3? Yes. So it works for both. Sorry, it works for the first one. Now we have to check to make sure it works for the second one. Here the value of x is a 2, so we put 2 here, plus y, which is a 3, is supposed to equal 5. 2 plus 3 is 5, so does 5 equal 5? Yes. So I'm confident that the solution is indeed 2, 3. So please make sure you take the time to check your work. That way you're 100% sure that it is a solution to the system. Okay, now moving on. Let's take a look at another example. Here, again, we're going to look for an equation that does have a variable that's already solved for. I'm going to go with this one. Why? Because I already solved for y. So I'm going to go ahead and write that one first, and then write the next one right beside it. So here I know the value of a y. The value of y is 3x minus 11. I'm going to go ahead and take this value and substitute it in for, you guessed it, y. Why am I substituting it for y instead of x? Well, because this is what y equals. So now I'm going to go ahead and rewrite this as 2x plus 3. Notice I left the 3 there. Now I'm going to go ahead and multiply this by y, which is 3x minus 11 equals 0. So one thing that I really want to make sure I stress is this 3 right here. Oops, I used a different color. That's very dark. A lot of students from my previous lesson often left out this number. Please make sure you're not replacing 3. 3 is still there. You're only replacing the y. Okay, so back to business. Now I'm going to go ahead and simplify what I have. I have 2x. We're going to distribute this, giving us 9x. Distribute one more time, leaving me with minus 33 equals 0. I'm going to go ahead and combine like terms, leaving me with 11x minus 33 equals 0. We're going to get rid of the constant first, leaving me with 11x equals 33. Last step, divide both sides by 11, which leaves me with x equals 3. However, I'm not done just yet. I'm going to go ahead and take this value and plug it in for x. Why am I plugging it into this equation instead of the second equation? Well, because it's already solved for y, so this is going to save me some time. So here I'm going to plug it in, y equals 3. Instead of x, I'm going to put 3 using parentheses, minus 11, which leaves me with y equals 3 times 3 is 9, 9 minus 11. Here, make sure you ask yourself, do you have more positives or do you have more negatives? You definitely have more negatives, and you have 2 more. So now that I know the value of y and I know the value of x, I can go ahead and say that the solution is 3, negative 2. Again, we want to make sure we always write x first and then y second. But again, we're not done. We need to check our work. So let's go ahead and do that. So now, quick reminder, you want to take the chance to just label quickly that, hey, this is my x value, which is 3, and this is my y value, which is negative 2. Now we can go ahead and substitute it into both equations and make sure they work for both. Y is a negative 2. 3 times x, which is a 3, minus 11. Here we have negative 2 equals, this is 3 minus 11. So we end up with negative 2 equals, there are more negatives, 2 to be exact, so this one works. Now I need to check to see if it works for the second equation, because remember, working for just one equation is not good enough. So here we have 2 times x, x is a 3, plus 3 times y, which is a negative 2. It's supposed to equal 0. 2 times 3 is 6. 3 times negative 2 is negative 6. 6 minus 6 is 0. So it checks out for both. Therefore, I could confidently say that the solution to the system is indeed 3, negative 2. Okay, so for number 3, again, we're going to look to see if we have an equation that is solved for a variable. Unfortunately, we don't have that. So we have two options. We can isolate one of the variables from the first equation or isolate one of the variables from the second equation. I'm going to go ahead and choose to isolate this one. Why? Because x is almost already solved for. We just need to get rid of this positive 2y. So let me go ahead and do that. I'm going to go ahead and isolate x by getting rid of this positive 2y. So I'm going to go ahead and subtract 2y from both sides, leaving me with x equals negative 2y minus 6. Now that I've done that, I went ahead and already solved for x. So what I can do now is take this value and substitute it in to the equation. But notice I'm substituting it in for x this time. So I'm going to go ahead and substitute it in for x. So now I'm going to be left with 3 times the quantity. Instead of x, I'm going to put negative 2y minus 6. I'm still going to add the 2y, which equals negative 14. Here, I'm going to go ahead and distribute, which is going to give me negative 6y, distribute one more time, minus 18 plus 2y equals negative 14. Here, I'm going to combine like terms. I'm going to combine a negative 6y with a positive 2y. There are more negatives, 4 to be exact, so negative 4y minus 18 equals negative 14. First, we're going to get rid of our constant by adding 18 to both sides. This goes away, leaving me with negative 4y equals, again, ask yourself, are there more negatives or positives? In this case, there's more positives, 4 to be exact. Last but not least, divide both sides by negative 4, which leaves me with y equals negative 1. But of course, you know we're not done yet. We're going to need to take this value and plug it into an equation. So now you need to think, which equation are you going to plug it into? The first one or the second one? Some of you are going to be tempted to put it into the equation that you manipulated. But to be completely honest, to be on the safe side, it might be a better idea to plug it into one of the original equations. So I'm going to go ahead and choose to plug it into this one because to me it seems a little bit more simplistic. So we have x plus 2y equals negative 6. I'm going to go ahead and take this y and plug it in for y into this equation, which is going to leave me with x plus 2 times the quantity. Instead of y, I'm going to write negative 1 equals negative 6. Now I have x, 2 times negative 1 is negative 2, equals negative 6. I'm going to add 2 to both sides, which leaves me with x equals negative 4. Now that I have both values, I can go ahead and write my solution. I'm going to say the solution is x goes first, which is negative 4, y goes second, which is negative 1. But again, we're not done. We need to make sure to check our work so that way we can confidently say that this is indeed the solution to our system. So let's go ahead and check that out. So here we're going to quickly remind ourselves that, hey, the x's are negative 4 and the y's are negative 1s. Once we've done that, we can go ahead and start substituting their values in. Our x is a negative 4 plus 2. Our y values are negative 1, and it's supposed to equal negative 6. Here we have negative 4. 2 times negative 1 is a negative 2 equals negative 6. So here you can add the opposite. I'm left with negative 6 equals negative 6. So this checks out. Here we have 3 times x is a negative 4, plus 2y, y is a negative 1. It's supposed to equal negative 14. 3 times negative 4 is negative 12. 2 times negative 1 is negative 2 equals negative 14. Here, just add the opposites. We're going to be left with negative 14 equals negative 14. Since it checks out for both, I could confidently say that the solution to this system is indeed negative 4, negative 1. Okay, so here we're going to just try one more example where, and you'll notice this is similar to the last one, where we need to look for an equation that has a variable that's already solved for. In both cases, you're going to notice that none of them are, but we can go ahead and choose to isolate one of them. To be completely honest, you could choose to isolate this x here or this x. Now, you're probably wondering why I'm not choosing to isolate y. Well, here it's a 3y, so the very last step would be to divide everything by 3, which might not be so pretty. Same thing here, you would have to divide both sides by 3 at the very last step. So, again, I'm going to go ahead and choose to isolate y. In this case, it really doesn't matter which one, but for the sake of it, let's go ahead and isolate this y. In order to isolate y, I need to get rid of this positive 3y, so I'm going to subtract 3y from both sides, which leaves me with x equals negative 3y plus 3. Now that I know the value of a variable, which in this case is x, I'm going to go ahead and take this value and plug it in for x. So I'm going to take it to the next equation, which is right here. Instead of x, I'm going to go ahead and replace it with a negative 3y plus 3. We're going to rewrite the rest as minus 3y equals negative 9. Here, there's technically, again, no one ever does this, but there is technically a 1 here. So distributing it really didn't make a difference. You still end up with negative 3y plus 3 minus 3y equals negative 9. So why do I keep stressing this? Because in the case that this was a negative x, you would have to understand to distribute a negative 1 to both. But that's not the case. But I want you to be very careful. So here, what I'm going to do now is combine like terms. So I'm combining a negative 3y with another negative 3y, which leaves me with negative 6y plus 3 equals negative 9. Here, subtract 3 from both sides to get rid of the constant, leaving me with negative 6y equals negative 12. Simply divide both sides by negative 6. And the negatives cancel each other out here, leaving me with y equals 2. But we know very well we're not done yet. We need to substitute this into one of the equations to get the other one. Now here, it really doesn't matter which one you choose, but I think using this one may be easier because it seems like most of the terms are positives. So I'm going to go ahead and substitute into that equation there, which is x plus 3y equals 3. I'm going to go ahead and take the value of y and substitute it in for y. So now I have x plus 3 times the quantity, which in this case is just 2, equals 3, which leaves me now with x plus 6 equals 3. We're going to get rid of the constant by subtracting 6 from both sides, which leaves me with x equals, again, be very careful, are there more negatives or positives? The answer is negative. How many more? 3. So now that I know both, I can go ahead and write the solution as x goes first, which is negative 3, y goes second, which is 2. But again, you got to make sure you check your work. So now that I know the solution, let me go ahead and check it. Here, reminding myself that, hey, my x is negative 3, and my y is 2. I'm going to go ahead and substitute it into both equations to make sure they work. Here, x is a negative 3 plus 3 times y, which is a 2, and it's supposed to equal 3. So here we have negative 3 plus 6 equals 3. Here, there's more positives, 3 to be exact, and it checks out. On this side, we have negative 3 minus 3 times y, which is a 2, equals negative 9. Here we are left with negative 3. Negative 3 times 2 is negative 6, equals negative 9. Simply add the opposite, which leaves me with negative 9 equals negative 9. Since it works for both, I can confidently say that the solution to this system is indeed negative 3, 2. Okay, so now that we've had some ample practice, I want you to go ahead and try number 5 on your own. So go ahead and pause the video. Okay, so I kind of left you with a tricky one. For number 5, of course, we're going to first check to see if we have an equation where one of the variables is already solved for. Unfortunately, we don't have that. So I'm going to pick a variable that I'm going to try to isolate. Here, of everything that we have, I think the best choice would be to isolate the x here. So I'm going to go ahead and do that by first subtracting 2y from both sides, which leaves me with negative x equals negative 2y minus 14. Now, notice we're not quite done yet. We still need to get rid of this negative. So if you want to think of it this way, imagine that as a negative 1 out front. So you're going to divide both sides by a negative 1, which leaves me with x equals, here the negative 1 is being divided to both terms, so now it becomes a positive 2y, and in this case it's going to become a positive 14. So now that we have that, I know the value of an x, I can go ahead and take this value and substitute it into the next equation in for x. So let's do that. We have negative 5 times the quantity, 2y plus 14. We're going to subtract 4y, and it's supposed to equal negative 28. First things first, we're going to distribute, which is negative 10y. Distribute one more time. It's going to be negative, we're going to do some side work, 14 times 5. This is 20. 1 times 5 is 5 plus 2 is 70. So that's going to be negative 70 minus 4y equals negative 28. At this step, I'm going to go ahead and combine like terms, leaving me with negative 14y minus 70 equals negative 28. First, get rid of your constant by adding 70 to both sides, which leaves me with negative 14y equals, again, I'm going to do some side work, 70, there's definitely more positives, but let's figure out how many more positives there are. There's going to be 42 more positives. Last but not least, we're going to divide both sides by 14, negative 14 by the way, which leaves me with y equals negative 3. So now that I know the value of y, I still need to find the value of x. I get to choose of whichever equation I want. I think this first one might be a better choice. It looks a little bit more simple. So let's do that. We're going to do negative x plus 2y equals negative 14. I'm going to go ahead and take the value of y and plug it in for y. So now I'm going to be left with negative x plus 2 times a negative 3 equals negative 14. So now it's negative x, 2 times negative 3 is negative 6 equals negative 14. Simply add 6 to both sides, leaving me with negative x equals, there's more negatives, 8 to be exact. Last but not least, divide both sides by a negative 1, which leaves me with x equals 8. Now that I have both, I can go ahead and answer the solution and say that the solution is, x is written first, so it's going to be 8, comma, -3. But, as always, in order to make sure that the solution is indeed correct, we have to check our work. So, let's check it. Oops. Here, quick reminder, x is a 8 and y is a -3. So here we have negative times an 8 plus 2 times a -3 equals -14. Here we have -8 minus 6 equals -14. Simply add the opposite, which leaves me with -14 equals -14. Check. Now for this one, we have -5 times 8 minus 4 times -3 should equal -28. -5 times 8 is -40. -4 times -3 is +12 equals -28. There are more negatives. How many to be exact? Well, let's find out. There's 28 more negatives. And guess what? That equals a -28 on this side. So I can confidently say that the solution to this system is 8, -3. Okay, so now we're on the very last one. Go ahead once more, pause the video, and try this example on your own and see how well you do. Okay, so let's go over the answers. Here, none of your equations was already solved for, so you actually have to solve for one. I'm going to go ahead and choose to solve for x. So first I'm going to add 3y to both sides, leaving me with -x equals 3y plus 9. Now all you need to do is get rid of that -1, which is going to leave me with y equals, first divide the 3y by negative, so it's going to give me -3y. Second, divide this +9 by negative, so it's going to be -9. So now I know the value of an x. I'm going to go ahead and take this value and substitute it in for x. So now we have -4 times the quantity, -3y minus 9. Write the rest as plus 3y equals -24. So here we're going to distribute. Negative times a negative is a positive. A negative times a negative is another positive. Plus 3y equals -24. At this step, simply combine like terms, which leaves me with 15y plus 36 equals -24. We're going to get rid of the constant first. Let's see how many negatives we have altogether. That's going to be some side work. Altogether, we have 15y equals -60. Divide both sides by 15. You're left with y equals a -4. But, of course, we're not done yet. We need to go ahead and plug that value into one of the equations. I think this one's a little bit easier, so I'm going to go ahead and plug it into -x minus 3y equals 9. So now we're going to take this value for y and substitute it in. So now we're left with -x minus 3 times -4 equals 9, which leaves me with -x. Negative times negative is a positive 12 equals 9. Get rid of the constant first, which leaves me with -x equals a -3. Divide both sides by a negative. These cancel out, leaving me with x equals 3. So now that I know both, I'm going to be able to write my solution. X is always written first, so it's going to be 3, -4. But as always, I need to first check my work before I can claim that this is indeed my answer. So if 3, -4 was my answer, I'm going to identify that x is 3, y is negative 4, and I'm simply going to check. Here we have negative times a 3 minus 3 times a negative 4 is supposed to equal 9. Here we have negative 3. Negative times negative is a positive. Here there's more positives. How many more? There are 9. So it works for the first one. But again, checking just one isn't good enough. You need to make sure it works for both. So here we have negative 4 times x, which is 3, plus 3 times y, which is a negative 4, is supposed to equal negative 24. Negative 4 times 3 is negative 12. Negative 3 times negative 4 is another negative 12, and it's supposed to equal negative 24. Here, simply add the opposite, and you'll be left with negative 24 equals negative 24. Guess what? It works for both, so I can confidently say that the solution to this system is 3, negative 4. So, that is going to conclude our lesson for today. Thank you so much for tuning in, and until next time, bye.